All right, so have you ever wondered how a SCORM course actually talks to an LMS? You know, what's really going on behind the scenes? Well, it all comes down to this hidden agreement. Think of it like a digital contract between the content and the player. And today, we're going to demystify that contract so you know exactly what's happening under the hood.
Okay, let's dive in with the single most important analogy to keep in your head. A SCORM player isn't just a passive window where content lives. No. It's an active participant. It's like a mini server that provides a JavaScript API. It's a translator that understands the language of the SCORM data model. And maybe most importantly, it's a rule enforcer, making sure both the content and the LMS are playing by the rules of the spec. And that's the real question, isn't it? If the player is out there enforcing a contract, what are the terms? What does the content expect to find when it wakes up? And what does the player promise to provide in return? This is the secret handshake we're about to decode. So, let's talk about this secret handshake. It all starts the second a player launches a SCO, or a Sharable Content Object. You can just think of a SCO as a single lesson or a module. The important thing is, it's not just sitting there passively. It wakes up and immediately starts looking for something very specific. And this right here is the absolute foundation of the whole contract. Before any tracking, any scoring, any communication can happen, the content must find a specific JavaScript object. This object is its one and only connection to the outside world. It's its lifeline back to the LMS. If it can't find it, the content is basically stuck on a deserted island, unable to tell anyone what's happening.
So this contract really has two main clauses, if you will. First, you've got the API itself. That's the set of commands the content can use. And second, you've got the data that's being passed around using those commands. Let's break both of these down.
First thing you absolutely need to know, the name of this all-important API object is different depending on the SCORM version. For the classic SCORM 1.2, it's looking for a nice and simple object named API. But for the newer SCORM 2004, it's looking for this much more, let's say, specific API underscore 1484 underscore 11. So, right away, if you want your player to be compatible with both, it has to provide both of these names.
So what can the content actually do with this API? Well, it uses a set of functions or methods that act like verbs in a language. Initialize kicks off the conversation. GetValue is like asking, hey, what's the student's name? SetValue is like telling the LMS, hey, the student just got a 95 on the quiz. Commit says, okay, please save everything we've talked about so far. And finally, terminate is the polite way of saying, I'm done, goodbye.
Now, here's a crucial point. Those API functions we just looked at, they're just the messengers. The actual message being passed back and forth is defined by something called the Commutable Managed Instruction, or CMI data model. You can think of it as a standardized dictionary of terms that both the content and the LMS have agreed to use.
And this comparison reveals a really big philosophical shift between the versions. SCORM 1.2 kind of lumped everything together with a single lesson status. But SCORM 2004 got smarter and split it in two. You have completion status to track if the learner actually finished it, and a separate success status to track if they passed it. This gives you way more nuance. Now you can track if someone finished a course but maybe failed the final exam.
Okay, let's put it all together and walk through the whole conversation. First, the player launches the content, usually inside an iframe. The content then immediately starts looking up the family tree to find that API object in the parent window. It calls Initialize to shake hands and start the session. Then, as the learner goes through the lesson, it's constantly using GetValue and SetValue to trade information. Every so often, it calls Commit to save the state. And then, at the very end, it calls Terminate to hang up the phone.
And this is the million-dollar question. It's the source of pretty much every SCORM headache you'll ever have. We've just seen the happy path, where everything works perfectly. But what happens when that content reaches out to find the API, and there's just silence? The entire contract just falls apart.
The number one reason that contract falls apart is because of a security feature that's built into every single modern web browser. It's not even a SCORM rule. It's a fundamental rule of the web, and it's called the same origin policy.
This brings us to the biggest technical hurdle in making SCORM work the way you want it to.
So to really get this, we first have to define what a browser thinks an origin is. And it's not just the domain name like example.com. It's actually a combination of three things: the protocol, so HTTP versus HTTPS, the domain itself, and the port number. If any one of those three things is different between two windows, the browser considers them to be from completely different places.
And here is why that matters so much. If your player and your content are both served from the exact same origin, it's easy. It's a piece of cake. The content can just reach up and talk to its parent Windows API. The contract works. But if they're from different origins, let's say your LMS is on one domain and you're serving your content from a different one, the browser itself steps in and says, nope, not allowed. Its security policy blocks that communication cold. And just like that, the handshake fails. The contract is broken.
Now, this doesn't mean cross-origin SCORM is impossible. Not at all. It just means you need a clever workaround. And the most common solution is to build what's called a bridge. This usually involves a browser feature called postMessage, which is specifically designed to let windows from different origins send messages to each other securely. Basically, the content packages up its API calls as messages, the player listens for them, does the work, and then messages the result back.
Okay, so how does knowing all of this help if you're actually trying to build a SCORM player? Well, understanding the contract and this whole cross-origin problem isn't just theory. It directly forces you to make some really important architectural decisions right at the beginning.
Right out of the gate, you're faced with these choices. Are you going to keep it simple and just enforce a same origin environment? Or are you going to build that more complicated cross-origin bridge for more flexibility? Where's the CMI data going to live? Just temporarily in the browser or saved permanently on a server? How are you even going to handle unzipping and serving the content files? These are the foundational questions you have to answer.
And hey, if you're building a tool for testing, a developer's playground, you need way more than just a black box that either works or doesn't. You need visibility. A great playground will literally show you the API calls as they happen. It'll let you poke around and inspect the CMI data model directly. It'll give you controls to restart or resume a session, and it'll even warn you about common gotchas, like the fact that you have way less space to save bookmarking data in SCORM 1.2 than you do in 2004.
So after all that, what's the one thing that really matters? What's the single most critical decision you have to make?
It really boils down to this. Your choice between forcing a same origin setup or building for cross-origin communication from day one will have the biggest impact on your player's architecture, its complexity, and your development timeline. Same origin is simple, it's fast. Cross-origin is way more flexible, but it requires a lot more engineering to build that communication bridge correctly.
So there you have it. We've pulled back the curtain on the SCORM runtime. At the end of the day, it's a contract built on a JavaScript API and a CMI data model. It's a contract that can be broken by browser security, but fixed with some clever engineering. You now know the terms of the agreement. The only question left is, what are you going to build with that knowledge?